Welcome back to video tutorial. In this session, we are going to look into counter. So in the previous session, we have looked into the flip-flop. So if you recall what we have studied in the flip-flop has two input and two output. So two input are set and reset, whereas two output are Q and Q bar. So as you know that flip-flop are the building block for sequential circuit. So therefore, flip-flop are going to use in order to construct the counter and as well as register. Now in this session, we are going to look into counter. So counter is a device, is a digital device where it will act as a storage device, where it will store the numbers. So counter has a relationship between the clock. So depending on the clock signal, your output will be displayed. So counter is a digital device where it will store the number and it has a relationship between the clock signal in order to give your output. Now with the help of number of flip-flop, depending on the bit of counter, so different number of flip-flop will be used in order to construct the counter. So if you are going to build 3-bit, then you are going to use 3 flip-flop. So we have two type of counter, synchronous counter and asynchronous counter. So let's look into the definition of synchronous counter and asynchronous counter. In synchronous counter, the common clock input is given to all the flip-flop and thus they are clocked simultaneously. Now, if you read once again, it says that in case of synchronous counter, so if you have 3 flip-flop, each flip-flop is given the clock signal at the same time. So therefore, that's why they are known as synchronous counter. So term synchronous refer to event that have the fixed time relationship with each other. So suppose you have a 3 flip-flop that are constructed synchronous counter. Now, if you give the clock signal to each flip-flop 1, 2, and 3 at the same time, so such type of counter is known as asynchronous counter. Now, let's look at asynchronous counter. Asynchronous counter, it is also known as ripple counter. The main reason why we call ripple counter is uh, each clock will act as a clock for another flip-flop. For example, if you have a 3 flip-flop, the clock that given to first flip-flop will act as a clock to second flip-flop. Similarly, second flip-flop clock will be used by third flip-flop. So therefore, such type of counter is known as ripple counter. Also, it is called as asynchronous counter. The flip-flop is clocked by external clock pulse, and then each successive flip-flop is clocked by output of preceding flip-flop. The term asynchronous refer to events that do not have fixed time relationship with each other. So in case of synchronous counter, each flip-flop is given clock signal at the same time. But in case of asynchronous counter, each flip-flop is given clock at different times. So therefore, such type of counter is known as asynchronous counter. So in both case, synchronous and asynchronous counter, it has two types. There are again two types. In the synchronous counter, we have up counter and down counter. And again in asynchronous counter, we have up counter and down counter. So first we'll look into synchronous counter. Now you know the definition of synchronous counter. Synchronous counter. The counter is clocked such that each flip-flop in the counter is triggered at the same time, and the counter is known as synchronous counter. So if you give the clock signal to the flip-flop in the counter at the same time. So such type of counter is known as synchronous counter. So look out here, this one is up counter. So this one is 3-bit up counter. So it is also called as mode 8 parallel binary counter. So it is also called as 3-bit counter, where you have 3 flip-flop 1, 2 and 3. So if you recall what we have studied in the flip-flop, I said we have 2 input and 2 output. So in case of flip-flop, in case of counter, we are using particularly the JK flip-flop. So you have 2 input J and K and output Q, K, A and A bar. Similarly, this flip-flop, we are labeling output as B and B bar and C and C bar for third flip-flop. So this one is mode 8 parallel binary counter. Now, so if you look closely, so you have a clock signal. So this clock signal is given to flip-flop A out here, and it is connected to flip-flop B out here. If you look out here through the N gate, and similarly, it is given to clock C through N gate Y. The clock signal to each flip-flop is given at the same time. So therefore, such type of counter is known as synchronous counter, and this counter is particularly known as up counter. So in case of up counter, the binary combination will start from 0 1, so which is given out here. So you have 3 flip-flop A, B and C. So flip-flop A is binary combination given by 0 1 0 1 0 1 0 1, and flip-flop B output will be 0 0 1 1 0 0 1 1, and this will be output from flip-flop C 0 4 0 and 1 0. Now if you do the count, when all the output at flip-flop A, B, C is 0, that is count 0 1 2 and till 7, then after 7 it will repeat again 0 1 2 7. So it should repeat after 7. Now if you look at the timing diagram out here, so you have clock A, B, C, D, E, F, H. So it should be 8 clock, 1, 2, 3, till here it is 8 clock till H. So we are going to count from 0 to 7. Now since we are using JK flip-flop in the counter, so JK flip-flop output change when at the falling edge of the clock. So at this clock, at clock count 0, so when you give the clock, so there is a change in clock at the falling edge. Such at the falling edge, your output will be changed. So at the falling edge, that is at 0. So you have output from flip-flop A, that is high. So you will have high, and this output will be high until the next falling edge. So that is at 1. And similarly, this output will be low till the next falling edge. And this will be high till next falling edge. So this will go on till count 7. Now, if you look at timing diagram for flip-flop B, now the output of flip-flop A, this clock, so you have 4 clock, 1, 2, 3, 4. Now this output will act as a clock for flip-flop B. Now you know that JK flip-flop will change the output at the falling edge. So therefore I said flip-flop A output will be act as a clock signal for flip-flop B. So therefore at the falling edge at this one, so your output will be changed at the flip-flop B, that will be high. And this will be go until next falling edge, that is out here. then your output at the flip-flop B will be 0. This 0 will be until the falling edge of clock at flip-flop A. And now your output at flip-flop B will be act as a clock for flip-flop C. So the JK flip-flop output will change at the falling edge of the clock. So therefore, this output of flip-flop B is acting as a clock signal for flip-flop C. So therefore, at the falling edge out here, so it will change the output from 0 to 1. Then this will be continued till the falling edge. At the falling edge, it will change to 0. So such type of flip counter is known as up counter, and this is under synchronous counter. And we have asynchronous counter. So here is the explanation. The clock is applied directly to flip-flop A. Since the JK flip-flop used to respond to negative transition at the clock input, so it is when it says negative transition, it means the falling edge of the clock, and the toggle when both the J and K input are high. The flip-flop A will change state with each clock negative transition. So whenever A is high, N gate X is enabled and the clock pulse is passed through the gate to the clock input of flip-flop B. Thus, B changes state with every clock negative transition at point B, D, F, and H on the timeline. So since N gate Y is enabled and will transmit the clock to flip-flop C only when both A and B are high. So flip-flop C change state with every clock at negative transition at point D and H on the timeline. So this is the explanation of up counter for synchronous counter. So in next session, we are going to look into down counter of asynchronous counter and also down up counter for asynchronous.